All right. We talked about radicals, right? How to simplify radicals. We talked about some things that couldn't happen with radicals and what we did. What did we talk about couldn't happen with radicals? It was like number 1 on your quiz.
They can't be on the denominator.
They can't be on the bottom, right? And so we talked about how we handled that. We rationalized the denominator, right? What else can't happen with radicals?
They can't be negative.
They can't have a negative under there until today.
See? No. I'm walking out this classroom.
So what we're going to do...
The rest is going against your rules here.
Well, I'm introducing you to a new set of numbers
So that's how
known as imaginary numbers.
Rules for a section, and you're gonna.
Why do we have to learn about imaginary numbers?
Because you can't have a negative under the radical, and I need to know what to do if I have a negative under the radical. So what I do, I'm going to let the variable I stand for the square root of -1. So now, based on what you know with simplifying radicals, do you agree that I could rewrite this way?
Yeah.
Same thing?
Yeah.
So, okay.
If it's an I equals square root of -1, then wouldn't it be like 2I equals square root of -2?
So you're going to use that one
under
as
the
negative,
radical,
because
yes.
it can't be negative.
Correct. So, you know, I like you to understand why. So the y is because I represents the square root of -1, but the generalization is that when you see a negative under the radical, negative under the radical, drop it and add an I. For always from now on. Okay. Now in general, also, let's see. I don't know why I'm saying general 150 times. Let's say I had the square root of -4. That's a perfect square this time. Okay. Usually when we have a variable, if you have something like a radical, the variable is going to come before it. But if you have just a number, then the variable, like the square root of 4 is 2, is going to follow that number.
Oh, because
Right? Because this is like I times the square root of 4, and the square root of 4 is 2. Are y'all tracking with me so far?
Where did you get the 4 come out of 5?
No, this is a new problem. That's why I did a new color.
Okay, I was,
Sorry.
because it was purple and I was like,
Yeah, sorry.
So -4.
So square root of -4 would be plus or minus 2i. Okay? You're still going to break down the radicals the same way that you did before. So if I had the square root of -18, were you not done? I can go back to this example. First thing I'm going to do is pull the negative out and put the I outside, right? How can you split it up? 9 and 2. So I'd have I root 9 root 2. What's the square root of 9? 3. So this time I'm going to do 3i, because remember the variable should follow the, it's just pretty math. That's just the way it should follow the whole number but be in front of any radicals or anything like that. Pretty math. All right.
this is not so bad.
Okay.
what does that smell?
Let me ask you this. If I is the square root of -1, okay, we're going to do some iterations here. What do you think?
What is the iteration?
What do you think I squared would be? Close. Think about if I squared this.
Negative square.
Square root and squared are opposite operations. What's left? -1. Okay. How about if I multiply by I again? So now I got -1 times the square root of negative 1. Negative square root of negative 1.
That doesn't make any sense.
Are we gonna have to do this?
There will be a few where you'll have to, when you're foiling out and stuff, you'll come up with.
Okay, yeah, well.
This is, but watch. There's only 4 you have to remember.
Us having a grip on the first, whoa, you're doing more?
Only through 4. What if I multiplied again?
It'd be negative square root.
1. If you square negative 1, because I squared is negative 1, square that, negative 1 times negative 1 is positive 1. And the cool thing about it is, they start repeating. This is I to the 4th, this is I to the 5th, I to the 6th, I to the 7th, I to the 8th,
Okay.
I to the 9th, 10th, 11th, 12th, and it goes on.
It's like a formula.
Well, you just have to remember the first 4. That's all you have to remember. All right, and we're going to use that as we go through solving. You'll see how that comes into play. Let's do some problems. Let's just do some practice. Okay, tell me what. Let's say that I had 2x squared plus 11 equals negative 37. How do you solve it? What do you do first?
Minus 11.
Minus 11. I got 2x squared equals negative 48. What do I do now? We got to this point in first block and someone goes, oh, I see the problem now. Okay. It was, just look.
Then you square root.
Then you square root. You see, there's going to be an I in the answer. I see the problem
They were
now.
trying to be funny or
Yeah, no, they were being funny.
X equals
Okay, so
All right, so now here I'm going to apply what I just learned, right?
X equals I square
Drop the negative, put the I outside,
I square root.
Then we gotta do 24.
and then you got to do 24.
Oh, 6.
6 and what? 6 and 4, because 4 is a perfect square. I'm going to put that plus or minus on the outside.
But it could be I. It could be 2I. 2I.
There you go, Walker. 2I,
2I is 3, right?
6. The 6 day. Yeah,
plus or minus?
plus or minus. You see? Does that make sense to everybody?
Thanks.
Want to do another one?
Yeah. Wait. I'm still lost. Hey, can you type in eyes on your calculator?
Let's do 3x squared. No. Minus 7 equals negative 31. Y'all try it first, and then let's do it together. All right. Several of you, I'm hearing the answer here and there. Let's do it together. Plus 7. 3x squared equals negative 24. Divide by 3.
You get 8.
You get negative 8.
I got that.
Square root.
I got there.
Good.
2I.
Okay, so, but look, the only new part here is because of the negative under there. So I'm going to write an I and keep the square root of 8, right?
Oh, I
I
don't
is
do all that.
negative
I just
1.
did
We
plus
just
or
did-
I is the square root of negative 1.
We just did the square root of negative 1. This one's 1.
Square root of 4. Yeah, no, that's fine.
Now this one,
Yeah, that's fine.
8.
8 is one of those that you get so used to seeing, you recognize it being 2 root 2 right off the bat. That's fine. Questions, concerns, comments?
Another problem.
Another solving one?
See. But no 8.
No 8.
No 8.
How about this one? 2x squared plus 18
I don't want to go home not knowing.
equals negative 72. Let's do it.
Wait, what's the answer?
All right, so subtract the 18. 2x squared, Mac, you doing all right over there? Negative 90. Okay. Negative 45. Square root.
I got it.
And then you do.
It's plus or minus 3 I squared.
Yes. So it's 9 and this is 9 and 5, so it's going to be 3i root 5.
So this is the easy part.
Okay,
Less
The
quiz.
I always goes outside of
the radical. Correct.
It always has to be the side.
Yep.
Well, if you don't put plus or minus, you only got one answer.
Oh, so you get half credit?
Um,
Oh, that's what you were talking about with the quizzes.
Yeah,
Right.
but
Okay.
when you get plus or minus
So
10.
you
Um,
get the whole thing wrong, you get half credit.
you got, yeah, probably get a little more than half credit.
Oh, thank you, because I put x equals 10.
Look at our parabolas we've been referencing this week on the board. Remember when we're solving quadratics, we're finding the intercepts? If I get two imaginary numbers for my intercepts, what does my parabola look like?
This way.
Look at this one. It never crosses the real number axis, right?
Yeah.
So it's going to look like this, or it's going to be down here, but it's never going to have an x-intercept on my
Gonna get
axis.
in the middle
Okay?
of a.
Do we got a graph?
No, I want you just to visualize what it is we're doing. I keep trying to make the connection so that it'll stick. But what we're doing is we're finding intercepts. We're finding zeros. All right, let's talk about what happens when we divide by an imaginary number.
Wait, we're not on complex numbers yet?
Not yet, almost.
We in those today?
Yeah. It's not bad.
That's what you said.
Let's say I have 5 over 3i. What's the problem?
5 over 3i.
Yes, what's the problem with this fraction?
I is the square root of something, so.
Y'all are on it. I is a square root, and I can't have a square root in the denominator. So now rewind, okay? When you had a square root in the bottom before, if you had something like, what was on your quiz? It ended up being like 3 root 2 over root 11. What did you do?
Multiply.
By 11.
By the square root, right? If there's something in front of it, you don't worry about it, right? You just multiply by the square root?
No, you multiply by what's in front of it.
So it would be.
No, like if it was, let me write it on here because I don't. If it was 5 over 3 times the square root of 2, you would multiply the top and the bottom by what?
Square root of 2.
Just the square root of 2, right?
Okay. I see what
You only want the radical to go away. You don't necessarily, I mean, it would just leave you more to, if you multiplied by this, I'm going to have a lot of reducing to do because I'm going to have 15 square root of 2 over 9 times 2. So I don't want to do, I only multiply by the radical, right? Square root of 2, square root of 2, right? I'm recapping from yesterday and the day before is what I'm doing.
It'd be 3 times square root of 4, which is.
This is
3 times 2,
separate.
which is 6.
I'm saying think back yesterday and the day before.
So it'd be 5 square root of 2 over 6.
Yes. Over 3 times 2, which is 5 root 2 over 6. So now take that same concept and apply it to the one with the I. Yes, ma'am.
But that's not what we did on the quiz, so I'm like totally lost.
Well, you did, but there wasn't a number in front of the 11 on the quiz. You multiplied the top and the bottom by the square root of
Okay, so
11.
what about the ones that are like,
It would be
Now, what's the radical in this one?
I.
I. So I can just multiply the top and the bottom by I.
Okay.
Okay? Now, and I'll put a note here. Multiply top and bottom by I. So up top, I got 5i, yes? Yes? The bottom, I got 3i squared. Now, tell me this. What did we say I squared equals? Negative 1. So when I squared is hooked to a number, what does it do to the number? What if it's already negative? Makes it positive. So I squared changes the sign of the number, right? Would you agree with that statement? So this becomes 5i over negative 3.
We can't have a negative 3.
Why?
That's what you told me on test and I got it wrong.
I got a question. What happens to I squared? Because I squared and I.
You can write it like this if you want.
Where the heck did you get that I squared from?
Let's write that in our notes. Anytime you have an I squared. It changes the sign of the number. So,
This isn't right.
5I squared would be negative 5. Negative 2I squared would be positive 2. Does that make sense?
Is there gonna be a problem on one that's like the denominator is I squared already?
If it's already I squared, then you go ahead and change it to negative 1 and you don't have a problem. I squared's not a problem in the denominator, only I. So, look at this one. What's the problem?
It would be 4I or negative 7.
These are
That's
what
correct.
gonna look like.
Some of them, the first part of them. So, the I in the denominator is the problem, right? So, I'm going to multiply the top and the bottom by I.
Would it always work like that?
Yes.
In these little ones?
Yes. If it's an imaginary in the bottom. We're fixing to do complex, but that's a whole other ballgame.
On top and then
Yes, so that's negative 7. Okay?
Do you have to write 7I?
Yeah, you can.
just a
Or can I just skip over the negative?
What happened to the box? I like the box
Hmm.
better.
Yes, Chloe.
Will the I be in the denominator by itself?
It could, and if it's just I squared, then it would be negative 1.
It's just I.
Then you would need to multiply it by another I, top and bottom.
I
Yeah,
got a question.
yes.
When you're doing our homework, do we have to write all them 7I squared out?
No, that's what they said. You can just go straight to negative 7. That's fine.
Are we thinking about this little thing Joanna's right now?
Oh, no.
About I equals square root of negative 1.
Yep, because we're fixing to think about that right now. Okay. Huh? Yes. All right, so let's talk about complex numbers. Complex numbers are made up of two parts. Okay? They have a real number part, and then either added or subtracted to it, they have an imaginary number part. So things like 2 plus 3i, 5 minus 7i, 6 plus 3i. Those are all complex numbers. They have two parts. They have a real part, they have an imaginary part. Does that make sense to everybody? So what I'm going to walk you through is how to add, subtract, multiply, and divide with complex numbers. And it's not as hard as you think it is. Because at the end of the day, I is a variable, right? A variable is something that holds a place and has a value, right? And so we're going to treat it just like we would any other variable if it were an x as we go through it. Yeah, Chloe, do you have a question?
Yeah, what if we were only doing to divide by
Well, it's going to be, we will have some division with the complex numbers, and I'm going to show you how to rationalize that denominator. All right. Let's do addition first. Addition. Let's say I have this. If I treat that I like any other variable, what do you do? Combine like terms, right? Sure. The I is still a variable, just like in... So, look at your real numbers. 2 and 5 would give me 7, right? And now look at the i's. 3i and negative 8i is negative 5. Easy peasy? And then you're supposed to say lemon squeezy. Thank you, Parker.
Wait, that's it? That's all?
That's it. That's adding. That's it.
Oh, this is adding, y'all. This is adding.
Hold on. Multiplication. This is going to be some whole new level stuff.
Again?
Yep.
Oh, God.
All right. But remember, I told you if you have a good grasp on the other sections, this is going to be fine. Because watch. All right. Subtraction. I'm going to do it on the same slide here. And I'm going to use the same complex numbers. Now, A lot of you did same, change, or like same, change, okay? If you're a same, change kind of person, you have to understand that you're subtracting this entire parenthesis right here, okay? So if you do a same, change, you have to do a same, change everything,
Oh, that's not happening.
okay?
Same.
Because what it is you're doing is you're saying 2 minus 5, which is -3. And 3i minus -8.
-5i.
It's 11i.
Oh, gotcha.
Minus a negative. So if you do same, change everybody here, you can see 2 and -5, 3i and 8i.
I like that.
Okay, whichever way you want to do it doesn't matter to me. Okay, just watch what sign is in the middle. Let's multiply.
How did I get -5?
Are you on the green one?
No, I'm on the white.
Okay,
Hey,
how did I get what?
you had plus 11i and I had -5.
Because it was 3i. It was 3i minus -8i. Because there was a minus here and this was minus.
Minus 8.
Well, but if you do same, change, minus a negative is 11, right? Multiplication. Let's do the same ones. Why not? Why not? It's turning backwards. 2 plus 3i. What was 5 minus 8i? All right. Distribute. Same as we did before. Be 10.
Oil.
Foil, yes. What's 2 times -8i? -16i. 3i times 5. 3i times -8i. Minus 20, somebody said it, 24. I squared. Absolutely. Now remember what happens when you have an I squared.
They changed inside.
This is not -24i squared. This is going to be plus 24. Does that make sense? So now I have 10 and 24, which gives me, and -16i and 15i gives me -1i. Multiplication. Yes, no, easy? That's what I hoped. I hoped you had a good enough foundation with the previous lesson that this was easy for you.
Yeah.
Okay. Division is the hardest, and it's not hard. It's the same thing that we've been doing. If you think about the way a complex number looks, a complex number is very similar to what we were doing on number 1. It's a real number plus an imaginary. We've been doing a real number plus a radical, right? So let's divide these two. Division. Let's do, what was it? 2, 3, 5, 8. 2, 3, 5, 8. I should join a what? Why? Because I sing everything? I don't know why I do that. I can't carry a tune in a bucket, but I'll sing something in a heartbeat. Okay, the problem is the I in the bottom. And just like over here, what do you think we can do to get rid of it?
Just do 5 minus 8i.
Change it. What's that called?
We changed it.
It starts with a C, you're right.
Conjugate.
Yes, conjugate. So, to get rid of this, we multiply the top and bottom. This time we call it a complex conjugate because it's a complex number. So what's the complex conjugate of the denominator?
5 plus 8i.
Yes. So now you can go home and tell your parents today we rationalized complex numbers by multiplying by the complex conjugate of the denominator.
And my dad would-
That sounds really smart, right?
And my parents would look at me and go,
Your dad, I was gonna say your dad would probably be like, show me. Or you just think that sounds smart, but it's not that bad.
Wait, no, maybe minus.
No. All right, so we got a double distribute problem here, top and bottom. So 2 times 5, and all of them are not going to have complex top and bottom.
10.
They might just have a number up top.
That's the only thing I know.
No, it's not.
Did we just multiply it? Oh, no, because we did the minus instead of the plus. Okay. 10 plus 16i plus 15i.
Minus 20.
Oh, yes, Walker, you are correct. I'm sorry. You're a step ahead of me.
What did he say?
He said minus 24, and I said, but he's absolutely right, because plus 24i squared. He skipped a step. That's fine. All right. Bottom, I'm going to just go ahead and multiply everything out, and then I'll change all my I squareds last step. 25, yes. Just like before, where we only changed the middle sign, we just changed just the middle. All right, 5 times 5, 5 times 8 is 40i minus 40i minus 64i squared. Is anybody confused?
Plus,
that's a big number.
then you
It's okay. That's because I made them up. This is going to be minus 24
why?
because the I squared changes the sign of the number.
And then you would come
I
up.
swear you
the bottom.
Robert, don't look so excited about that. That's a cool thing. It gets rid of your I squareds.
trying to wrap my head around all of
10 plus
Well, you're not wrapping your pencil around it, so.
it. Yeah, 'cause I'm wrapping my head around it.
Oh my goodness. All right, 10 and negative 24.
Once, can you?
10 plus 21, I don't know. Can't wrap it twice.
16i and 15i. If I've done it correctly, there should be no i's in the bottom. Those are gone. 25 and 64 is 89. Tell me what you think. That's the answer and that's the lesson.
That's easy.
That's it.
30G?
That's an 89.
Let's see if I-
It's 9. That's 89. 89.
It's not 80.
We've got so many